Our next presenter is Micah. Micah Blake McCurdy does ice time distribution drive score effects. Micah is a pure mathematician by training, whose main research is in graphical languages for computation. He dabbles in data viz and statistics and has written for Hockey Prospectus, Hockey Graphs, Silver 7 Sens, as well as providing data and visualizations for hockeystats.ca. He is a bad analyst and a great maker of infrastructure. He cheers for the Senators and does not know how to skate. He is barely even a Canadian.
Well, thank you all for having me. I have to confess, it does say in the bio that I'm a Senators fan, and so you can take it as a mark of my dedication to this fine conference that I'm here while the Senators play their 82nd game in the season. While they have not yet clinched, neither have been eliminated. So we are. In fact, I would take it as a favor if people would yell if interesting things were to happen. There we go. That should be a little bit better. So I'm going to tell you, I don't believe in suspense, although Eric persuaded me to change the title game to the public. I'm going to tell you something that is not true. Ice time assignments are not what drives score. And if you don't believe me, that's great. And slowly I will convince you as we go. So Eric already introduced some of these things for me, which is great because that saves me a fair bit of time.
Use the page down button.
That is better. So first of all, what a score effect? I'm going to tell you what might cause them. One of the things we're going to investigate for what a possible cause of them is that maybe it's because better players or worse players are on the ice at different score states, and then I'm going to tell you that that's not true. That's all. So this is, in fact, this is sort of unusually scientific, if you like, in the sense that we're going to look hard at something where the answer turns out to be no. There's a very, very strong temptation to only present things where the answer turns out to be yes. But it's not really the way of progress. So, score effects, what do I mean by score effects? In fact, there's a whole umbrella catch-all of what we mean by score effects. And today I'm talking about, so the very, very short version is that trailing teams dominate. They get more of the game, they get more of the puck, they get more of pretty much everything. They get more of the goals. The various effects are different depending on exactly what you're looking at. But if you're losing, you're probably doing a little bit better. That it's maddening in a way, but it's awesome if you're a fan. Today, we're looking at 5-on-5 shots, and I use shots in the broad sense, which is to say all goals, saves, misses, and blocks. Guy takes a shot, it's a shot. So here we are. So what are score effects on shot rates? Well, let's just take a look at this. There's going to be a whole lot of graphs. There's a handful of graphs of different kinds. There's a bunch that follow this pattern. Offense on the x-axis. To the right, more offense. To the left, less offense. Defense, inverted, as it were, so that the numbers go up. I mean, it's weird enough to have the numbers go down. You can't do that. So up at the top, bad defense. Down the bottom, great defense. So this is what you do, what your opponents do. And so this is just, this year, this is the league shot rates at score state at 5-on-5. So, and it's home and away all matched together. So of course, and the red line is just 50%. So tie, we get about 55 shots per 60 minutes and about 54 shots against. Sorry, it's the same number, about 54. Of course, that has to fall exactly on 50-50. That's an obvious check. And then, and the diagonal gray lines are percentage points. So 50%, 51%, 52, 53, 54. This slightly darker, 55, 56. So I'm not a big fan of percentages. I find they're really misleading, and I really like to show things, to show the pieces of the things that are in the percentage. It's very easy to say, oh, this is 53%. Well, this is also 53%. And then you graph them and you realize that one of them is a whole bunch of offense and a whole bunch of defense doing a whole lot of offense against, and the other one is the opposite. You know, if you just say, well, this is percentages, you start saying things like the Dallas Stars are the same as the New Jersey Devils this year. And they have similar course of percentages, and they could not be more different if you actually look at the components of what you're talking about. So, and also, this is, in fact, this slide is exactly a graphical version of something that Eric just showed you. And the numbers are almost exactly the same. If you're losing by 1, you get about 4% extra. If you're losing by 2, 6%. It's a huge difference. Doesn't seem like very much, 6%. But 6%, the difference between 6% is essentially what the Kings did all year, give or take, on average. The plus 2% you're looking at about -6 there. So for -6, just for comparison, is about what the Habs have done, give or take. So that was all the league match together. And just for one idea, we can verify one point of conventional wisdom, which is that score effects should be different on the road and at home. And so the gray line is exactly what I already showed you. The blue line is just the home teams, and the red line is just the away teams. So in fact, it's exactly the same data, only flipped. So I just put it there twice so that you can compare the different pieces. Because of course, this -2 for the home team is that +2 for the away team. It's exactly the same. But so this is deliberate redundancy so that we can make comparisons down here. This is the home team when trailing by 2. This is the away team when trailing by 2. They push. This is the home team down by 2. They really push. So you see something that is conventional wisdom that you already know, that if you're winning, if you're losing on the road, it's not such a big deal. If you're losing at home, it's a huge deal. And you can see it. So this is nothing but causes here. This is just output. This is just results. But so we already see that whatever people are doing, it causes something that you already know, that people try harder in terms of output. I try not to, I'm very slick with these phrases like try harder, and not saying, you try harder. So one common misconception about score effects is that they only affect the late stages of the game. They're definitely stronger as the game goes on. But so this is a graph where we have game time on the bottom. So we're only looking at stopping at 60. And this is the home Corsi percentage, so home shot percentage. The teal line is even. You'll notice it starts at about 53, and it winds up at the end of the game just over 0. So the home team always gets a little bit more of the puck at tied scores, but that effect becomes smaller and smaller as the game wears on. By the time you get to the end of the game, between 55 and 60 minutes, the score effects are extremely dramatic. These are leading teams getting eaten, and those are trailing teams pushing incredibly hard. But you notice that even by the time you're into 20 to 25 minutes, already the score effects are very well established. So early in the second period, score effects are already obvious. And even so of course, there's not a lot of data for being up or down 2 or 3 goals or more early in the first period. That doesn't happen so often, but variations of just 1, you can see already from the beginning. So this is down 1, this is up 1, so the other way. And you can see that there's a small but marked difference which starts from the very instant at the beginning of the game. It's not just a third period effect. Don't listen to people who tell you this. They exist. They're out there. They talk to me on Twitter. So what I'm interested in for this particular talk is what causes score effects. We've known for a long time. Eric mentioned the groundbreaking work from 2009, but that they exist. But exactly what causes them is tricky, and Eric's diving into one aspect of it for playoff performance. So this is exactly the same stuff that he mentioned, only repackaged with a slightly different look. So the first idea is ice time assignments. Maybe the players are different. Maybe you're getting lots of certain players in certain score states that matters. So that's essentially a coaching choice. We're going to put out more of this guy, less of that guy. And then, of course, there's 2 sides to this ice time assignments for people's. Pardon me? Was it the bandage out? I'm wearing a special shirt. Oh no, I'm sure. You'll see that tonight. If you come to the meetup thing, you'll see me and I have like a custom zip shirt. But then again, there's 2 pieces to that, right? There's ice time assignments for the trailing team, and there's ice time assignments for the leading team that could be different. And there's changes in coaching systems. The teams might actually play differently by instruction when up 1. Maybe you dump the puck in a lot more. Maybe you chip them off the boards. Maybe there's 1,000 different possibilities there. And there's individual risk aversion. Maybe you're playing the same system, but you personally, when you're sizing up something, just because you know you're winning, you evaluate the same situation differently. So there's no change in what you're supposed to do, but you know your options are. If you're coming down like this, and this is the look you get, these are your 2 choices, and you make that choice differently because of what you know about the score. And then the fourth thing, which I'm always leery about for reasons of quantification, but which people bring up all the time, is intrinsic effort. It's very easy to say, well, players are professionals and they play it 100% all the time, but we all know that's not quite true. We don't know how to measure that, but it's possible, and it's worth recording here. I'm not going to talk about it any later than this, but it's possible that people who are trailing actually try harder. They literally play hockey in every aspect better than teams that are winning. So so what happens in the remainder of the talk is that I'm going to talk to you about ice time assignments, and then I'm going to tell you that whatever it is, that's not it. We're gonna find an effect here, we're gonna measure it, and we're gonna find it's very small. So here's some examples of some individual teams this year, and we're gonna keep that gray line is the thing I showed you in the first slide. It's gonna appear on every single slide. And so if you see, this is a team like Vancouver, this year, Vancouver is the averagest of teams. Everything is this year. Literally, it is unusual how average they are, it's kind of freak. But you notice at tie, they play almost identical to the league. Down one, almost identical. Down two, don't push quite as hard. Up one, they push a little harder. They're a little better. Sorry, not quite as good, I beg your pardon. And up two, they really sit back. But still, mostly very much in line with league averages. So I chose them because they're the most boring, the ones closest to that gray line. So here's Chicago this year. So, but then you notice the pattern is exactly the same. There's nothing strange about it. You just took the entire pattern and just shifted it over. A little bit better defense, a lot better offense. So this suggests that something that in terms of like whatever it is that's causing it, this basically says they do the same thing that people normally do, only better. But there's no difference in the shape, which is the interesting thing. Except that kink at -2 is quite impressive too. When they're down two, they give up just a little offense, and but actually they get tighter. There's something very interesting there. Although of course there's some small sample stuff there too. They don't trail by two very often. So here's Los Angeles, and this is really distressing. So first of all, notice that it's just, especially defensively, it's just off the charts. It's not literally. I made a chart. But what should really surprise you is what happens when they're winning. Here's tied. Here's up one. Here's up two. A total variation of 2%. It's very, very small. Whatever's going on in Los Angeles, it's much the same when they're up as when they're tied. When they're losing, then they suddenly turn their depth up. And we were talking before. This is most teams when losing. This is Los Angeles when losing. It's ferocious. This is when losing by 2. That's insane. So that already. So then there's something very interesting here. So what's going on with that? So there's not a very average team just in terms of possession effects. Here's Detroit, the weirdest team in the league. So notice again that at a very broad level, it's much the same pattern, only down. Defensively, much stronger. Offensively, not so much stronger. Like here, the difference here -1, losing by 1, losing by 1. Offensively, essentially no extra. Basically no extra offense compared to the league. Defensively, it's unreal. The change is hugely lower. Also, notice that the pattern itself kind of broadly looks the same, except you can just imagine, like you took a normal pattern that would go +2, +1, 0, -1, -2, and you took +1 and -1 and made them much better. Much better offensively, much better defensively. So there's something interesting, something definite and deliberate happening at +1 and -1 in Detroit. In fact, this comes up before, and I mentioned this on Twitter. Every time, I'm a fan of certain teams and I'm just like other teams, but everything I do for statistical analysis, I always look at all 30 teams, every time. Never let myself get fooled just by a few teams. And there's something slightly eerie about looking at Detroit data. It always looks like there's something more going on. And here's Washington for some local content. Very, very typical. Really totally quite ordinary, except all of a sudden, -2. Why is that? that is a team possessed. That is as good as anybody in the league. And so if you see Washington come back from deficits, that is not a surprising thing, in a way. I mean, this is a surprising thing. And it creates an unsurprising result that, yes, they come back when they're down a lot. They're just incredible at shot generation. I don't think we need to say anything about that. So I'm going to look at some actual deployments. So let's take a look at some deployments. This is Ottawa. And so this is, I'm only going to have a few of these, and I'm going to go through reasonably quickly because I don't have much time. But this is down 2, down 1, tie, up 1, up 2. And then the other axis, and notice it goes down to 0, instead of 25. In fact, they all go 25 to 45% of the available ice time that you could have got. So this is how much. So Carlson, when you're down to 45% of the time, he really is out there all the time. But as the Senators start to win, then he plays less and less and less. So they're optimizing his ice time for losing. That makes sense. He generates an enormous amount of offense. The other players, not a great deal of variation. A little bit. Here, Kutch, especially early in the year, he didn't get trusted very much when they were leading. But you can definitely see that sort of superstar effect for Carlson. The other players, maybe there's some effects there. Cody Cece, doesn't care, doesn't matter. Exactly the same. Take your regular shift. That's all. So what about Detroit? We noticed they were really weird. So do we see anything there? First of all, notice nobody's up in the 40-45. They're rolling their ice a lot more. And we noticed there was something going on at +1 and -1. It's not super obvious here. You don't really see any big changes. You can just eyeball. You don't even have to look at the numbers. You can just look at the regions between -1 and 0 and just look. Do all the lines look straight? Well, then it must be more or less the same at -1 and +1. So you see a little bit of movement, not too much. What about the Detroit forwards? Well, again, you can sort of eyeball it. It's mostly straight except between 1 and 2, and all of a sudden the lines are getting rolled. You see all the numbers come together. Everybody's getting an even share of ice time all of a sudden at +2. At +1, it's more skewed. At -1, the skew is huge. But you can see all the players are stretched out. Certain players are getting lots and lots of ice time, and it's not especially relevant here. That is Gatsby, of course, up the top. But you start to see, here's a deliberate optimization to -1. They know it, like they know what side the bread is buttered on at -1, and at +2 it doesn't matter, roll them all. So, and then here's Los Angeles. Drew Doughty getting the hero treatment again. Much like Carlson, when they really need goals, he's the one. You start to see a similar effect. Lower pairings, there's a lot more movement. And so you think to yourself, okay, maybe there is something here. Just looking at a handful of examples. So let's try and measure it. How are we actually going to measure it? Well, first, let's take a look at the LA forwards. Again, look at this big drop, a whole bunch of guys. The faint ones are people who didn't play very many games. And again, you start to see a little bit of the skew. But up at the top, it's not so skewed, so I'm not so sure. Okay. So the idea here is score adjustment. And one of the things I did a couple years back is I made up a method of score adjustment that works for individuals. Not just for teams, but for individual events. So the idea is, if you're winning and you get a shot, it's worth more, because shots are hard to come by when you're winning. If you're losing and you get a shot, it's worth less because they're easier to come by. That's the valuation idea. And exactly what does it look like? So this is like the other ones, only slightly different. This is if you get one shot and this is the home coefficients because it's different on home ice and it's different on the road. So if you're up by 3 and you get a shot, that's worth a lot. You actually get 1.14 shots in the accounting. And if you let in a shot, then it cuts. Sorry, if you permit a shot against, it doesn't count for as much. You're already up by 3. Of course, they're going to get lots more shots. That's just what we observe. So those are the coefficients, and you see that there's a similar sort of pattern there. And so the idea is you can use this, and this is the central idea. You can use this to measure the score-adjusted performance of every single player on the ice. So you look at what somebody does at all score states to get an idea of their intrinsic, i.e. not in those individual score states, but their intrinsic rate of generating shots and rate of suppressing shots. And so then we're going to look at each score state, and so we're going to say, if you deploy this guy when you're losing by 1, look at his total adjusted rates, not his measured rates against teams who are playing at +1, to get an idea of theoretical deployed roster strength. So it's just a weighted average of all of the score-adjusted possession numbers of all the players, weighted according to how much they were on the ice in certain score states. And so then we can actually just take a look, and so we'll take a look at some of those teams. So here's Detroit. So it's not quite what we expected. First of all, you see that they're putting out better players at -1. When they're tied, they're putting out defensively equal players, but without the same offense generation. At +1, they sit back. At +2, they sit back a lot. And here at -2, also, they sit back a lot. Well, it certainly looks like a lot, but then you look again at the axes. This is shots for, in fact, it says per minute. It's supposed to say per 60 minutes. These lines are still 1% lines, but we're not seeing the massive variation, 12, 15, 20% total variation. The total variation from +2 to -1, the most extreme, is what, 4? Yeah, 4 percentage points. Much less. Between one thing, we're not even a full percentage point. Sorry, no, I lied. These gray lines, I had to add more gray lines because they didn't fit. There weren't any gray lines to see. These are actually tenths of percentage. This is 0.4 total percentage point. It would fit all of this entirely between 2 of the lines on the graphs I showed you earlier. What about Los Angeles? They were also extremely dramatic. Well, here we see something a little bit more like what I expected. +1, -1. They're the ones that get the love. They're the ones that get all the extra players, all the best players you've got. Those are the 2 most important states. Tied, especially the transition from -1 to 0 is the one that gains you the most in the standings. In particular, more than you lose from +1 to 0. But again, total variation about 0.3%, very, very small. And so then let's jump straight to the whole league. If you average out the entire league, now the total variation is within 0.2 percentage points. So, and you notice that the defensive variation, the quality of defense deployed, is very, very narrow. Teams are essentially icing the same caliber of defensive player all the time at every score state. There's a slight push towards offense when you're down by one. That makes a lot of sense. But the point is, you can look at all these effects. This particular effect of who actually gets put on the ice turns out to not have a very large impact. So this is one idea. If you want some takeaways, there's two obvious takeaways. One is look elsewhere. Right? The effect is extremely strong, and we worked out in a qualitative way how much of the variation is due to this particular effect, and it's almost nothing. So the variation's got to come from somewhere, so you got to go hunting for it. So the obvious attack for me is looking at quantified versions of systems. Looking at, why are people making the decisions that they make? This is the sort of thing that you would aggregate together with the kinds of projects that we've heard talked about earlier in the day. But and the other thing is, in fact, and just as important is, don't waste your very limited time and effort on this thing. In particular, if your coaches are deploying guys that you don't think are suitable for -1 or +1, it doesn't really matter. And so in particular, that means we can all lower our blood pressure just a tiny little bit. And that, I'm afraid, is all.